basic tutorial. A lot of people start out with this triangle and don't know what to do. It's like, what do you do? So some cases this triangle should be centered when it resizes. All kinds of things. And we can do this in Linux. We could try Mac. I do have the Mac example open. Scrote. Uh-oh. The Mac died again? And I will operating systems and replicate what we did from scratch. Caffeinate itself. Oh, and my mouse this right when I start to W Notepad++, and I could show maybe a later video on how to get all this to work. Glue is GCC O for output, input, the C++ file, include library glfw, include probably need that. It's teleporting. Yeah, I really need to figure out how to clean the lens a good way. This little triangle. We can try to do it in Mac OS, but iOS, I mean, but it doesn't work. Oh yeah, you get these like cool issues with your PCs just kind of older like mine. I think I'm and I want to use metal. Special. Well, we could load glfw and glue and see how that translates in Mac. And it's using some of these other colors, so the setup is kind of ready. It's a little nicer running this than the iOS emulator that just destroys the resources, and my screen didn't update for some reason. Okay. I'll just load up into the render file here. I really need to clean my mouse. These teleports are so dangerous, like you can drag the file in the wrong place. Yeah, so 6 vertices. I modified that from 3 to 6. And I added more triangles up here. I had to add more triangles. It didn't let me just add one because it's doing like triangle GL, where you can't just like call it triangle draw, but draw 4 vertices. work. Okay, so it's like 3 vertices. Yeah, I did rename this to smoke. I'm gonna try out the smoke simulation over there, and it does say it's like a smoke slash steam, and let's make a new instance. So you have to like code this up, have glue.h, glfw.h, and iostream for command prompts. So kind of debug. There is later a way to get rid of the command prompts, but when you start out, you kind of want it, because before you get text rendering to work and get good at that. I kind of wanted to do text rendering today, like I did the other day, but I kind of got that to work, so there was more to it, code bases that I want to integrate, but we'll just stick to kind of easy today, not hardcore do everything. Okay, so this is just triangle. This is vertices triangle. One way we could do this is just define everything all in one shot. It would be nice to use vector. So I'll just name this underscore basic underscore 1. And then we'll make our compile command first. Make sure it compiles. This is compiling with mg32. Oh, I have to like go back and see where I got it, but I believe I got it on just that open source code site. You could also use this one. This is, I think, more standard common. And so is this one. I think when compiling things like, let's see, let me Google it real quick. Yeah, SourceForge, I mean, when compiling, I don't want to say LVM, but Mesa 3D, but you need LVM for Mesa 3D, so you kind of need to compile it with something, and it has to be linked to something the same. But on Windows, you got the whole McDonald's app in your hands or something. Linker thinger. L files that don't match. Library files, I mean. So we also logged into Raspberry Pi. That's what's going on here. So I have this game in here. Like a basic, really basic setup. Kind of like no GLFW, but we could load GLFW. I do have it on Linux. Just don't have the remote control set up all the way. All these like little technical problems. So with this, also kind of just reading through the code, we have a basic shader, a cube, which is one of the things we want to do, and cube indices. So this does it with using indices. It doesn't just define all the, it uses some matrices, and it translates a little. I don't know, oh yeah, it does rotate. So it does kind of like glue on IT than GLFW on IT, but except it does it more of the OpenGL ES 2.0 way. While we're coding an OpenGL 3 on the computer, and OpenGL ES 3, and this is OpenGL ES 2 on the Raspberry Pi. And on Android, it's OpenGL ES 3. So let's get like 2 objects. Let's just get a triangle. I mean, let's get a rectangle and then a triangle. Okay, so this is a triangle, right? So we kind of want to move it and make it smaller. So based on my paint example, we kind of want to do this, kind of. And then maybe we could like rotate the cube later. There's all kinds of cool stuff. But I kind of actually wanted to keep this short. So if it's halfway through the screen, X would start at, I guess, 0. So let's throw this triangle to 0. Just doing that. Well, we want to put 0.0. Let's see if we can compile our basic sample. I believe I wrote down the command up here already. Or maybe I didn't. No, I didn't do that. Let's put the command up here. I have a bunch of wild notes up there. Like implementing, that's to get sound to work. And that's not even like the half of it. That's just to get the library up. Since we're called basic, we'll put basic into the name. Make sure I don't override my standard example for the tests. Because they come with samples, like a lot of these big libraries come with samples and they have more files. And if you could test out basic samples, and then we execute our GCC O exe name or binary name, and our C++ file, it's compiling in the libraries. So we get this triangle here, smaller, save space for the, we'll just make it from 0.05 to 2.5. It's just a really easy mod. Let's just test it again. And the thing I like about this is how fast you iterate. Uh-oh. Something's wrong there. We executed our old code, not our new code. There it goes. Yeah, it's smaller triangle. Okay, so now we need to draw a rectangle. I kind of wanted to those old coordinates so I don't have to type. So let's start it at negative 0.75, comma, O. What's the y coordinate going to be? I want to do the same thing, but it's actually, we want this one. We want 0, so it's kind of like in the center. It would be better if it was 0.25, negative 0.25. It would make it like go up. And then triangle coordinate 2, where would that be? My brain's dead today, so if this is like this, it would be the other x, so negative 0.25, and we want it to be longer, so this will only be 0.25, so this will just be 0.0, but we don't want it to be 0.0. Let's start at negative. No, 0.0 is fine, it won't override because we're not overriding on the x. The y doesn't move actually in that part of the triangle. According to the other triangle, we need to, we'll use that y value down here and just copy this value here, and we need x value here, which will be the same as the first x value. So this is just going to generate two triangles, right? Let's reiterate. I forgot an f somewhere, like behind this. It's better to put the f's. Sometimes it'll let you not, and then you go to a different system and all of a sudden you're just like lost of why things broke again. We don't have the escape key working, we can make it work too. So we drew that. Why didn't the other triangle show up? This triangle is quite long, but it's going to be a long rectangle, so that's fine. So it is because I didn't call draw arrays correctly. It should be 6 now because there's 6 points. Let's try that again. Okay, so there we have that. We can get the y's straightened out too here. Set this to 0, set this to negative 2.5, 2.5. Let's make sure we did that right. Okay, we did. Now, let's draw the second part of this triangle. See how to do this part. So I'm just gonna copy. It's usually 0 to 1. Got it somewhere, or we could just guess. Which one of these points is the? We can draw this out. I think we have to draw this out. So then guessing is not fun. It's just irrelevant. So we drew this. Which one is point number 1? Point number 1 is going to be the most negative. How does this look like again? So which point is upper? Negative and negative. Yeah, it's the more negative one. So I drew that wrong. Well, I could draw it right like this. So 1 is here, right? I just didn't draw the top of this triangle yet. Draw it like this, underscore. It's a little longer than this, so let's pretend these slashes are a little more long, but whatever. Okay, so we have that part of the triangle. We know that that's 1. So we're not going to need to draw 1 again. We're going to need another coordinate. Which one is the one with the other y? It's this. No, this is 3. So we will need to draw 3 and 2 again. In which order? I do believe it matters for certain things. I don't remember the mathematical. So let's just draw 3 again. I believe that they would draw 2 again. Something tells me draw 2 and then 3. I'll leave that as 2. Do a little bit better job. I don't have enough space here to write triangle. Now I've messed up my triangle by trying to write triangle. Triangle. We'll just write it like that. So it makes absolutely crazy sense. And just 3 kind of closer. Okay. And then constructing a rectangle. A lot of fun. Okay, so we know we need point 3 here. What are the coordinates of point 3? It's actually, if you were doing this in an array, it would be the 2 index. This is point 3, so we need to override this so it's lower. So now we need to draw point 4. So point 4 is going to be the other value. It's going to be whatever maximum. So it's going to be 0.025 and 0, because we've never had that value before. You could figure that out because it's like it's a rectangle. It's pretty simple, but it's like in the beginning to do this, it's like a headache without picturing it or doing it on paper first, and then it's a lot easier. So this is our other triangle. See what we got. See if this was a genius job or this was just like me being a really bad programmer. We did get a rectangle, but our triangle disappeared again. What happened? Oh, buffer thing. Maybe we should just write all this dynamic, but I don't want to. The whole point of this is to exercise the buffer array to get to when you do go dynamic, you have these basic shapes already kind of here, and then you can vectorize them. Alright, so we got that. Do we need to recompile? Yeah, we do. Okay, rectangle and triangle. The next one should be cube. Cube. Let's take a look at our cube example. I believe I have one. It's not this. This is like multiplayer server. which this would be a good practice, like get this to work with cubes and then actually start inserting 3D tiny models top of the cubes or something, and then add other physics primitives like triangles and planes, or rectangles, sorry, planes. Well, rectangles transform into planes. Okay, so here I haven't really talked about some important aspect, which I was like, I'm actually confused here, because where's the shader? This is not running a shader. But for the Raspberry Pi Linux OpenGL 2S, you do need a shader, I believe. I wonder if what would happen if you didn't. Would you just use default pipeline? It might. I've never tried that actually. It's an interesting thing. So let's just draw the first face of the cube. We do have a slight problem here. We'll draw the first face of the cube first. So we'll do the same thing. There'll be some... Okay, so this is our triangle. Just comment this. Triangle. Vertex 1. I have to use copy paste here. But this does clean things up to when you read it again. After you've added another 10 lines of code, it will just like gets to be really disorganized really fast. So top left. Is this top left? I believe this one is top left because it's the most X lower and Y lower, I mean higher. Top left. So this is top. No, how's those? There's two at negative. No, this is not top left. This is top left. It's the only one that's... let me look at this again. So the one that has both those points is left bottom. So we actually should figure out left bottom first. This one has a point and this one, no. This one has a point with this one, and this one has a point with this one. So this is bottom left. This is top left because it matches with this one. They're both lefts. So this is... What was the other thing? Right. The right one. It's bottom. So bottom right. Now this can change depending on what kind of triangle this is. This is kind of like rectangle notation here. Alright, so we need another square. These are 2D coordinates. So somehow glue and GLW, OpenGL just does 2D coordinates, and it's basically because of this 2 right here. Like, what if I change this to 3? I would have to add more. I would have to add another vertex attribute for Z position. But first we could just get the first face. Since it goes to 0, so it would be 0.25. To the other two always start at 0.0. So 0.0. Then it goes 0.50. I'm just following the pattern of the top one. I'm just like, oh, okay, if the value goes up, then just go up. And then now it's the lower value for vertex 3 of cube that's just being a rectangle now. And this is obviously, oh no, it starts at negative and then it becomes positive. Sorry. So negative, negative for y, then the third y is 0. And then we copy the third. The third starts at 2, 5. Actually, some of them will repeat, but the y does not repeat on the third one. Does it? Yeah, it repeated. Whoops. Undo that. Okay, now it's 5 with the 0. 5 with the 0, and the last one, it's the lower and the upper. So 0.25f, 0.0f. Do we need a comma at the end one? I don't remember if it matters. If it'll complain. Uh-oh, we did get something wrong. Maybe it's this comma. Something is really wrong. Oh, we forgot a comma up here. Alright, something is stupid. Oh, again, we need to draw more triangles. Add another 6 triangles. So 9 plus 6 is 15. Uh-oh, drew the wrong one. I executed the wrong program. Okay, so we've screwed it up. Correct rectangle, and I didn't put it in the right place. X coordinates position. Uh-oh, that's so bad. What did I screw up? Oh, the last point should have been unique. Put this to 12. Erase this. Recompile it real quick just to see what it looks like first. Okay, now we need to move it over. Let's move it to 250 to 75. Move the X over. Make sure it looks like the other triangle, other rectangle. Cubed, so we need it to be cubed. Switch to projection with the matrices by using the shader and the resize. It will have the right perception and it won't like do this weirdness. It's like a lot of work. Sometimes you just like go so far ahead you forget about all this little work. Okay. So we got this basic part of the triangle. Now part 4. It's basically going to be 0.075 with 0, but I don't want to jump ahead, but I already kind of did. So I'm just gonna put it there anyway. And then it is 2, triangle 2. Triangle 2 repeats, right? 2 and 3 repeats. So we take 2 and 3 and just copy paste real quick, and then just reiterate. Oops, I recompiled it twice. It's okay. And then we don't get it because we forgot to draw the last 3 triangles because I had the safety on, so it wouldn't just crash and we wouldn't go through this troubleshooting for a long time. Okay, so we got another box. I mean another square. Okay. Somehow I have to transform this into a cube now and rotate it. Now the next one is to draw some rectangles on top of rectangles according to our spec. This is our spec. MS Paint spec here. Down. When you can do flax, this is part of the spec with little math. Get into matrices by rotations, either with quaternions. Just taking a look at the 2 basic quaternion formulas and what they're for, and just listening to the math tutorial from GDC. Quaternions. Equation tells you to divide the angle by 0. I mean by 2. Sorry. I just like dividing things by 0. But yeah, and why you would want to use quaternions to after you kind of just do basic linear algebra. I think we have to touch on that formula anyway. Alright, so first let's kind of I'm just adding the comments to the vertice numbers because we will have 36 vertices for this cube. That's going to be quite annoying. Now in order to do this, we need to add another axis. To add another axis, let's just do that first. What you do is for vertex attribute pointer, switch this to 3 and times this by 3 because it's going to be offset of the, it's going to be destroyed. That doesn't change this number though, it doesn't change the triangle drop count, but what we'll need is add another 0 on the back of this because that's what that means. It means there's another part of the array. And we'll see if it just destroys our display, and if it does, I'll add the shader and the projection matrix, and it should fix it. Because this is the next crucial headache step, and you have to read about shaders and projection matrices, but you don't have to know about it. You could actually just code it. Alright, so it worked without destroying anything. That's good. It means we keep working. But there's sort of an issue here. Now, I can get this out for hours upon end. Or we could just go code in C, finish defining my cube for OpenGL with this first rectangle square face. Okay. It just might not get the errors I need. I mean, it might not. I should be able to see. Okay, that looks right. Back face, left face. Now, there could be more explanation to this. Like, you could really mess around with the cube for a long time. But for our intents and purposes, let's just copy this. Like, you could double check this code. It's like the homework or something. And we'll just paste it in here. And right now, since we have 15, we just added 5 times 6, which is 30, so this changes to 45. And do that. Compile it, run it. Alright, so nothing changed. What happened here? So now we need to like rotate something. Now, since I have the Raspberry Pi version somewhere, let's try 11 and then go to 15. Here we do have the shader, but this is the OpenGL ES 2.0 shader, which is version 100. So we have these cubes, the front and back. Why is it only 2 things? Okay, whatever. Projection matrix. Alright, heat makes a rotation matrix, and then he multiplies the MVP, sets that as the shader. So we may need the shader here in order to use the projection. Oh, he recycles all these points. He only needs the back, the front and the back to create the whole cube, because he recycles the indices. So that just was a confusing explanation. So let's get the projection matrix, the rotation matrix, the transformation matrix, the model view projection matrix, the temporary matrix used for stuff, the uniform location set, and just copy paste this or type it out, I don't know. We'll put this into the draw loop, I guess, which is this while. Let's put it in before the binding of the VAO. This could be done a little bit more elegantly, but okay. The angle, which is part of the state, will become some global. We'll just make it float angle 0.0f. Then we've got to add a shader. Why should I add the shader? I'll just look at my text example code. Okay, here's some shader. I don't like these shaders. I actually should have redid them. But okay. Let's just define the shaders up here after angle. You have to recode these shaders really. We'll just make the color some color. We only need view projection matrix, so let's remove text color for now. Get rid of the sampler or the texture, the color, and the texture coordinates. Set this to version 140. Remove this core keyword. And then just set color equal to, oh, vect out color. Let me go look at another sample real quick. Oh, good. This is incomplete somehow. I don't know how. I don't know what that was. Okay. Yeah, that they like dumping this color out using the out vector color. Now that's fine for OpenGL 3.3, but for like OpenGL 2, because this can be OpenGL 2 conformant also, and 3. We'll go to my game that I'm making. Uh-oh. It's the same code. Now what do I do? Oh yeah, there's a way to make a custom cursor too, but that's something else. Triangle game 5. Oh, there's even 4.3 shaders in here. I remember doing all this and trying it when making the game. Triangle game 12, because I kind of like built it up. Started adding random code, slapping it all together. Okay, so here's a version 140 shader. It's defined with string. And how is he pumping out the color? He is using out that color, yeah. So we could use this color thing. Because sometimes it's gl underscore color. So it's like sometimes I want the shaders from Raspberry Pi. Yeah, gl frag color. Like what if we did the shaders like just really basic. In position. And then let's go back to our thing. I opened way too much stuff. Okay. Now it could be defined as const char or string. Let's say ours is string. Let's do that. Try to be at least somewhat like kind of C++. We need to include string. We need to say namespace std using namespace std string, or we could put an std in front of string. GL position has to be. Uh-oh, I deleted MVP. Huh, okay. To go back a little bit here. Yeah, we need the projection matrix. So, insert this like this. I believe it could be even 120. Like the lower you go, the more support you get. So this is a 4x4 matrix, the projection matrix. We need that in our vertex shader. And the vertex position, before the vertex position, or after. After. Get rid of these quotes. And the new line thinger. Okay. Let's delete this. Include string. Then, if this frag color thing doesn't work, I think I have the code to debug the shader. So the color will be red, and green is 0, so it's not green. Blue. So red mixed with blue is yellow? I don't remember. We'll see what it is. It'll draw that onto the shape. And this needs to be multiplied times the projection. But it's called MVP. It's not just a projection matrix. It's all the three matrices, and it's being multiplied on CPU. We could do it on the GPU too. So when the GPU does the multiplication, it's actually faster. But we'll do the skip fast one, MVP. So we need this MVP. Make sure we set it here correctly. MVP location. Since we didn't use the state variable, we have to get it and then state it. I'm looking for the code. We have to get it, and oh wow, what is this? Some gnarly thing. Oh, frag starfield. There's like a starfield shader. This is how that looks like. I believe that's like off of shader toy, me trying to convert it. Yeah, like I was trying to do that, just take a bunch of shaders and start converting them. I got really excited about all these shiny things. Go back and like just start doing really basic few texture coordinates. But we're not even going to shade any texture or anything. We just need to compile the shaders. We just need like a basic setup for a shader compiler. I believe there was one in one of those other files, but yeah, create shaders, link the shaders, set the uniforms, bind the vertex array. Let's do it like this. Load buffers, create compile shaders, program ID. So we need to compile the shaders kind of like before we do this vertex ID stuff, I believe. Do it here. Just gonna need like one vertex position, set one mat uniform, the program will be a global called GLU int program ID. We don't need this trace thing. It's better to create a shader function, with a check for the error, because then you know what line code it is. And a lot of the programming actually surrounds just... Okay, so we need to get the vertex, attribute not the attribute position, we need the uniform position. How do we do that? No, just erase this. So we created the vertex and the fragment shader, which will be vertex shader.cstr fragment shader.cstr, and it has to link them together, so we haven't done that. Oh, here it does it right here. There could be an error though. It's good to like do this in a function. It really cleans things up. But where is he getting the attribute location for oh yeah, uniform location. Need this. And we need the uniform location for matrix. It's still using the state thing. I'm gonna have to like figure that out. So we need the width and the height to be defined. And the angle, have to erase the state pointer thing. We'll fix things. Our matrix is called, I believe it's called MVP. Yeah, so this get uniform location, just put MVP and name it MVP. It's a GL int. Put that into a global. And later on, it's like you put these into classes or their own objects, structs, or classes within the structs. Set it to something, set it to 0 at least. Okay. Oh yeah, we need to set int width and height. Set int width is equal to 800 and height is equal to 600. That's just kind of standard for the screen size that's streaming at. It's easier to see and everything. But when it creates this window, you could actually specify. It's only creating 640 by 480. So just plug in width and height so it matches our projection matrix. So it's like correct. And rename this to basic shapes examples. Okay, so we did a lot there, but we haven't done one thing yet in order to get this to work. I believe we're going to get some error if we try to compile this right now. And we're going to get... We're not even using the shader, yeah, so we get that. So we have to set this MVP. I believe it did have the code to set it. Oh, okay. So we have to put in here MVP because it gets the uniform location up there. And it sets it to MVP. So here's the problem. We like named the location variable the same thing as the matrix variable. So we have to go change that. That's my bad. I didn't realize. Yeah, so this MVP has to change to MVP location. And up here, MVP location. Then we have to use shader. There's this special function OpenGL has called use shader. I believe like Vulkan, you have to like make a shader pipeline, but you still have to like use a shader, kind of like this. That's why like some people say don't learn OpenGL before Vulkan, but then it's like it does make sense to learn it. Okay, so here, once we attach the shader, we link the program, we create the program. Oh, we don't have this link program function. And this will also report errors, will it? It won't. But it'll link the program. Let's go to like a really gnarly part of the game I have. Like nice game 44. And take a look at link program. It should be updated. Because when it links it, it could also do error checking. Alright, it links it, it attaches the shader, it gets all these attribute locations, but it doesn't do error checking. Not in this one. Compile shaders. Compiles it, cannot compile shader, C message. This one does error checking. Compile shaders, string shader type. So that one's good. Attach shader, detach shader. Where does it compile the shaders? I believe we need 2 of these functions. Yeah, so after we create the shader IDs, compile shader 1, compile shader 2. This does it in such a stupid order. It's like loading the texture here, then compiling part of the shader here, linking it here. Okay, so when it links program, it needs to compile them before it links them, but it's both calling these two functions. So here, our program, we've defined the shaders, compiled the shaders, linked them, but we don't have this compile shaders function or this link function. I need to paste that in and make sure I don't have anything extra in there, like all this bind attribute location stuff. Our bind attribute location is actually just position, POS. We don't even have a color. Yeah, and so we have a vectint POS times the MVPs. I'm trying to simplify this as much as possible. So we link, compile the shader string in its type, based on its type. That gets passed into the API, then this function takes care of the errors. And it'll also tell you the actual line number on the shader that's wrong with this C message printout. Cannot compile shader, and it'll tell you a line number, which is good. Then always should turn the shader ID, and then we pass these two shader IDs that we did with compile shader into this part of the function called link program, and it attaches to a program ID it creates with GL create program, and it on the fly compiles the shader, which is really cool because sometimes in Vulkan you need to actually do some sort of thing to hot reload the shaders, and here it's a little easier in OpenGL to hot reload the shaders to code it. It basically, you don't hot reload it, you just compile it at runtime. And GLSL, same thing. It's a little more than OpenGL can do the shader part. It's better to learn from this than go to that, basically what I was trying to say. I have some typos here. Frag shader CSTR. Okay, let's see where the errors are. This should by now be ready to cook, except for a few typos that I did. Okay, so cout is not defined. There's some sort of error because, okay, compile shader string. So I don't have namespace std. I'm trying to keep that out. Okay, 122. These are just standard type errors. The problem is I'm mixing printf with cout here, which is my bad, but it works for this. But sometimes when you're doing Android, we're gonna have to use out. It'll work on Linux though. Let's see what time is it? 9:30. Okay. So line 84. I'm just fixing all the little errors. Some of them aren't real big errors. Like the next one is just putting math.h up there since we need it. We could also try to use special math functions within SIMD to speed things up, but that's too advanced for this. Okay, so it compiled. Let's see what happens if we run. Okay, so good. Somehow we get our basic shapes again. But nothing seems to happen because it didn't execute the shader. Why? Because I don't see that color that we defined being displayed. So we forgot something. We forgot to say use shader. We literally forgot to see this program ID. That's our shader ID. And when you do GL use program, so program in the OpenGL world means the shader program. The graphics CPU program for both the vertex and the fragment. The pixel. The pixel shader in HLSL is the fragment shader in OpenGL or GLSL, and the vertex shader is the shader for the points. Now there's also a rasterization process in between those, but we don't need to know that for now. It's go and read about it and be like, oh, so Vulkan can skip rasterization and just do all this, and it's just okay. So before we set uniform location, before we even get this location, I believe we need to use the program. And I believe it'll have still the program running, but a lot of people like to use program every part of the thread, but let's see what happens if we don't. I mean, every part of the loop. Uh-oh. Everything turned back to what it was. What happened? I executed the wrong thing. Alright. What have we done? I saw our shapes. Yeah, so we got our rectangle, our triangle, and our cube. There's no, like, lighting. And I believe it's rotating the MVP matrix instead of the objects. So what if we stop rotating them? Let's stop rotating them. Set them at some constant angle. And keep doing this. Oops. Alright, so we can see that our cube, maybe get closer. Oh, we can't get closer like that. I promise that like this part would work. It actually kind of does work now. There's another problem though. Yeah, like now their location is kind of not changing, but it is. Alright. I believe this is a perspective matrix. So those stay 2D, that one went 3D. Now we have to do rectangle on top of rectangles, but we need color though. Another attribute now, which is going to add a lot to this. So let's draw another rectangle. We'll just copy the first rectangle to make this quick. And we'll change its Y position. Let's see, let's run this again. It's a bit far away. I kind of want to zoom in. I feel like zooming in, like... Since our position, the translation matrix... Let's ask it to zoom in for us. My brain is dead. Code in C++ to zoom in about 2x. See what it thinks about this. It's gonna do the dynamic version. So yeah, it agrees about the MVP being times. Doesn't look like it changed the shader code. It's not changing the points. It's really interesting to have LLM do this because it doesn't think like human and it screws up in the stupidest places. Enable depth testing for 3D rendering. Yeah, we could actually enable the depth testing, but it is, we could see that it's 3D. Well, because it's the same color, it's hard to see it, but aspect FOV near far planes. Okay, yeah. So in the we just have to modify projection matrix a little bit. Just a little mod just to help us, because we only have the aspect inside the projection matrix. This is going to be old. Let's put this old, comment it out, and keep it here in case we do the rotation later again, or want to. And it's the same variable name, so it should all match up. And you can see it's a 4x4 matrix. And then we have the FOV for zoom and near. Okay, so let's just see if it works. Alright, aspect was not declared in the scope. Okay. And we will just copy paste it, and it should work. Good, aspect. We destroyed it. Fuck. 2x zoom. Let's try 1.5x zoom. Mathematically, maybe that's not correct, but maybe it is. Oh, what? Oh. How is that different from the other matrix? Okay, so aspect FOV. FOV didn't change the aspect, it's still 1. FOV is being plugged into this one. Okay, this one, near. Also, be afraid of these words, near and far. I've seen them break things. There's some sort of reserved words in C++ or parts of some other libraries that are very common. So don't use near and far. Use like NF. Or maybe don't use that either. One letter variable is very bad practice, but whatever. They're actually better than... Okay, so far will be 100 plus near, which is like 0 practically. So 100 divided by 100 -2. Okay. We might need to do this. Code in C++ glfw3, add mouse scroll zoom to code above. The problem is we have this angle code also, and it might be that other thing that's screwing us up. Alright, but the scroll callback shouldn't mess us up that much. We add this scroll callback, which will change zoom variable, which will be global. It pumped it into a file, okay, whatever. Still processing the file. Sometimes it goes back and changes it while you're just... And it sometimes gives you the right answer that it changes. It's really funny. So we have to like take these variables. Just take some of these. Aspect will leave here, I believe. It's not nice setting everything to global, but it's just for demonstration purposes. So when we create the window, make context current window. After make context current window, we have, because it uses a Windows handle or a X11 or a Wayland handle, depending on which version of your mouse. I mean, running on my mouse is just terrible today. It's like, did somebody like give me this mouse after they've used it? Oh yeah, probably. They could have swapped it out again. Okay, before blah blah blah, make context window, and oh, the mouse screwed me up. So that was definitely the mouse's fault. Okay, we added the scroll callback. That's the reason I told it to do the scroll callback, so we wouldn't have to deal with mouse coordinates yet. And I can't tell if it works. Well, it compiled, so it should be working. Okay, let's see. Let's enable rotate again. And then just rotate it, look a lot faster. We need to add that attribute for color, and then just add the two next things before it gets too late. This would be nice to do this in Android too, and Raspberry Pi. That way we cover maybe Mac. We cover all 4 OSs. Maybe do that next time. Support this. Angle. My eyes are already not seeing anything. Angle. Let's leave that. That'll be the default value. I like hoarding code. It's good. And nope. We destroyed our sample even more. When did it get destroyed? When I added this new matrix. Yeah, it could be that far near error thing. Let's put the old matrix back. It's the matrix math not lining up right. And so there it is. So how is he using zoom variable? Zoom is equal to a meeting. No, zoom is equal to whatever FOV is divided by zoom. Oh, he's clamping the value. This might be the problem. Let me unclamp the value a little bit. Set the default a little bit. Alright. 0.1 and 10. Set that to 100. Set that to 0.1. Set the zoom to be defaulted to normal. What was the normal one? 0.5. If 1 is divided by 1, you get 1. So let's set that to just 1. 1 divided by 1 will be 1. So it should have the regular matrix. And then it does matrix math, but it's like I shouldn't have scrolled, I should have waited, but why would it screw that up? Okay, so if FOV is 1, Okay, so far as 100. If you're ready to move to Vulkan, I could adapt the code, and it kind of like knows certain stuff. Okay. Far and near. What if we set near to like -10? I think it's like not gonna work. Tried to do something like this before, I don't remember. Freaking projection matrix. Just like read up on this again. Oh, there's our stuff. It's like zooming by. But that doesn't project it right. Bad thing to do. Destroy a default value like that. Okay, far, 1, near, 0, -1. I guess our FOV is just like off. We'll add a little debugger thing. What I don't get is why the scroll is a type float. Maybe that's the issue? I don't know. It should be an int, I believe. Standard API. Just find the projection matrix in here. Oh, this one just doesn't use one. It's a 2D game. So it has 1 and 1. That's the projection matrix it uses. Okay. Well, could sit here all day and do this part. Let's see if we just inject that in there, what will happen. And fix it off of that. Should be rotating, I think. The other one was -1, 0. That worked. Let's just do -1, -1. Show everything between -1 and -1. I think I believe that means. I thought that was what that meant. Crap. 1.0 and 1. Plugging values into the matrix. I'm still questioning the translation matrix. I see it. It's like up there. What if we don't multiply it by translation matrix? It's doing this -2. Translate cube away from the camera. Yeah. That's what these two operations do. We'll just like cancel out translation matrix. Translation matrix is here, but this is where it does the multiplication. By doing that, math library does it different, a little different looking code. Okay. set our default projection matrix to, I wonder what that -1 does on the Z part of the matrix. We define aspect globally. No, we don't. It's actually defined here. What? Aspect was not declared in the scope. Oh. That's like a little problem. I've broken the whole sample. That was so good. Now it's so stupid. But I think getting rid of the translation matrix, it will fix things by using the standard perspective zoom in matrix. I think, I hope. Well, nope. Why though? Far near FOV should be FOV divided by height and width, right? I think we need that transformation matrix for this to work. The projection plane. Yeah, because we need this matrix. Yeah, it was right. Whoops. So we're changing random stuff. Crazy. And then, yeah, it'll start looking crazy as you change that. So what if we set Z to like -1 for everything? We can't because the cube. Okay. Just tell Grok to do it. Set camera position in front of plane, triangle, and cube. See what he says. Yeah, it's better to write a camera class, like really. How come it gave us this value, the opposite? 5 point. Okay, now we got the view matrix. I should have done this all the way through. Then we do some view matrix stuff. And we do rotation matrix stuff. There's projection view and rotation matrix. Multiply those. Here's the translation matrix. I guess this is the translation matrix now. I guess we erase temp. Alright, so it does rotation view, rotation, and it does the math. I need to uncomment this out. Instead, make a temporary matrix, view model matrix. But what's inside temporary matrix? Like, what's it multiplying? There's a view matrix. Oh, it's multiplying projection matrix times view matrix, putting into temp. Then it's multiplying temp matrix by rotation matrix and putting into MVP. Alright. It says up there in the comment, but it's like, what does the code say? I have to like read the code, make sure it's not hallucinating something. Then we need this matrix multiplication function that it like made. It's like our like main math library function. So actually kind of know what we're doing here manually without using GLM graphics math library. And we have what a nothing again. wonder why. He probably doesn't understand where the position actually is. Camera up position, camera center, camera up right here. Look at point. Camera at 2. Make it so the camera is modified by mouse move XY. Let's see. It's really, I'm gonna move the camera to like -10. Z equals 0. That should actually make, no, well at 10. Maybe +10? Well, we could reiterate fast, so. Nope, didn't do it. Other thing we want to do is rotate faster. Okay, let's make a new sample file. So done writing this. Okay, now we're just getting crazy because we kind of went off scale from the other thing. I could have not done this. The 3D cube is what really messes with it. I should have just transformed the 3D cube. I should go back in the sample. Okay, I'll do this. I'll undo some of this stuff. Basic to, let's see, ++. Then we'll go to this. New basic 1 underscore grok 1 dot c++. Just go back to where we were in control. We didn't use grok that much. And we'll try the grok samples again later. Here's the callback. Doing this. We want to go back to like when we just added the shaders. And we just had the simple projection matrix. Like that. I wanted to zoom in a little, and I believe that was just modifying FOV. That's what it said. So I believe it's like this parameter or something. If I increase that. Let's put it to 4. Yeah, like that. Okay. I don't know if that was a good idea. I was trying to change the z-axis. But I think I just did something invalid by doing that. But that actually wasn't too bad. What if I put a 1 right here? What would that do? Oh, good. Now we could see the z-axis like sticking out. I think we need to just put 0.1 so it doesn't look ridiculous. Okay. Kind of looks. This was 2. Oops. No. Don't make that 2. Make this 0.1, 0.5 instead. Oops. Okay, ridiculous again. 2.5. Okay, so we can see the cube, but it'd be nice to rotate it. What would be nice, save old value, so once we get the cube to rotate, it'll look right. That's the index of the matrix, so I have to save it like that. Okay. Now what to do is just change the attribute, and we add 2 more attributes. We gotta add color and position. Oh yeah, we gotta add that other plane. Kinda like went into camera matricing mode. That's the problem with this, there's a lot of things to explore. Okay, let's just copy this rectangle. Can we just set the positives to negatives and the negatives to positives? Probably. Yeah, like this value over here, the z. We are going to need the z for the sub-rectangles later. Okay. Okay. So we need to switch. So 7. So it is going to be the same, but different wise. 120.25. No. 0.5 to negative 7.5. No. Negative positive 7. No. No. 1.5 0. Solid negative 0.25s. And this one is 0.75. Because like, so it's under the other thing. Okay. Let's make sure semantically it's correct. We need 6 more triangles on the screen. 45 plus 6, 51. Oh, we screwed something up bad. Uh-oh, let's go back. Okay, the X should be right. Something weird is with that cube. Let's change the projection matrix back. Default everything. Okay. Then add the triangles and draw everything. Where's the other one? What's it drawing? Where's this one? It's weird. It should be over here. So 36 plus 3, 39 plus 6, 45 plus 6. I need to add another color. I'll just print the size of the triangles. And like not worry about it for a second. Size of triangle 608. So a float is 4. There's 3. So divide by 3 times 4. Let's see what that gives us. It should give us 51. 50. How is it 50? this 36, 45. Should be one more. Unless I'm missing a comma somewhere. Oh, I am. That was a really big mistake right there. Okay, that should fix everything. Let's get rid of this. Maybe we'll keep it here for the next debugger session if we ever have one. Okay, good. It's in the wrong spot. Need to fix that because that's not how I drew it on the paper. So we're always going from 0 to from negative 2.5 to 0. So we need to go from negative 7.5 to 5.0. It's really confusing because you have to replace values. Negative sign and unsigned. Let's see if that works. Okay, it did. I got it to where I wanted it to be. Okay, now I need 4 more rectangles like this, but smaller inside this one. The different z value, the higher z value, like 0.1, so that it indexes in front of it. Okay, so the first one, just copy paste this. The x will be higher, so that's lower in this terms, it'll be 0. The y will be a little lower. Right, okay. And then this will be 1. So number 2 this will be a little higher. We use 5, so this will be 30. We may want to change that, but okay, let's just copy paste real quick. Try to get through all of them. So it's by 3. Okay, the fourth one, 30, 7, 2, 1, 5. Okay, what is this? This was 1, this is 2. Uh-oh. 4 and this is 5, right? I'm confused. 1, 2, 3, 4, yeah. Like, so we're just changing the values slightly, so it's not that hard. So we need like 4 of these, which I already screwed this up, but it's okay. We'll fix my screw up after I'm recompiled here. See if it compiles right. It does add 6 more to our draw call. So what's 1 plus 6? It's 57. That's like super math. Okay. See that we drew it somewhere. The problem is color now. We drew it too long. It was supposed to be only, I want to say 6 pixels long. So this should be start at 70. 70 minus 6 is equal to 64. Yeah, 64. Whoops. Let's change this 30 to 64. Now the Y is right. These are so bad. So horrible looking at this. But usually it goes through that type of processing though. It looks horrible at some point and then later on. Those are the indices. Keeping track of these indices here. Okay. Let's make another 3 of these really fast. So for those 64, 2 units apart from 64 will be what, 62? So let's do 61F, replacing 70 with 61F. Then we're replacing 61 minus 457F. Okay. It's a little confusing, but whatever. I might get a comma here and there butchered. It's number 2. Number 3, okay. 57 minus 2. Actually, we did a minus 3 last time, right? We went from 70 to, no, 64 to 61. So 57 minus 3 is equal to 54. 54F, replacing the 61. And then 6, is it? This one from 61 to 54, that's 4. This one from 70 to 64, that's 6. Wait a minute. Did I screw this up? Maybe. Let's just keep going. Could fix that little irritation later. Maybe it's a longer character, like a W and M. Because that's usually what it's going to be. That's the demonstration. Caching characters. Okay, so we have 54. 54 minus, what, 4? 50. So 57 just turns into 50. How many do we have? This is rect 1, rect 2, and rect 3. We need one more rect. I'll just copy paste 3. Call it 4. Okay, minus 3. 47. 44? No, 41. And then, good, okay. Bad thing was, okay, this is plus 6 plus 6 plus 6 plus, wait, 1, 2, 3, 6 times 3 equals 18. 18 plus 57, 75, whatever. Okay, so we got them, but for some reason they're sticking out, but whatever. I think that's because there's Z. This is causing that. They were supposed to be a little bit longer here, maybe we need to add more later. Let's add the colors. Alright, so we're not going to do that uniform color crap. We're going to actually add another variable thing, I mean attribute. Let's start with the this thing here. Bind attribute location pose and attribute location attr color to, that's the most important one, bind attribute location. Let's add it to the vertex shader. In vec4, this will add the color. Then we're going to pump out another vec color. We're going to say, in the end here, out vec4 v, which stands for, and then we'll just pass, we'll say v attribute underscore color is equal to attribute color, and then in fragment shader we're going to get color also, but it's going to be an n, and it's going to be the v attribute color. I think you can directly somehow pass the fragment shader, but I think this is how you also do it. Okay, so then we take this color, spec 4, and we can directly set it to fragment color. We could also do some kind of cool stuff in here, like write if statements, and also pass in the position, and based on the position, do weird stuff. And we could also pass in the, I believe, the uniform matrix. And based on the uniform matrix stuff, we could set its color too. Okay. Let's just pass in uniform matrix so we can mess around with the shader later, just to like mess around with this later. Okay. Let's hope our shader compiles. It should. We just have to add the colors now. Let's make everything red, with the transparency of 0.75. So 1.0 F, 0.0 F, 0.0 F, and 0.7 F. And just concatenate that to every vertex. And we have 75, so in Notepad++, this is fast. We have to add, I think, 2 more lines of code elsewhere after this. We have to add the bind attribute locations thing, and enable, disable, for the attribute locations we use. How far along are we? I think the longest part of this adding will be the cube, and then the cube will switch around the colors to give it like more 3D look. There is a way we could also programmatically mess with the shader, but I think like porting it next will be the next fun thing, and then messing around with the cube's lighting. Okay, we're almost done. Now doing it like this isn't like good. Like, this is why it's nicer to write a class, but also it's a thinger that will like allow you to do this all in one array in one shader. Okay, so we need to do vertex attribute pointer, enable vertex attribute array 1. So vertex attribute pointer will go from 3 to 4. The stride will now be 7. So 7 times size of float. And this start location, I have to double check my other code. Make sure we get it right. So the stride location for the second part will just be at void 0. Yeah, because before I used to do weird stuff like this. I used to be like void 2 times float, because I thought it wouldn't know, but it does. It's like automatic. It's like I was way overcomplicating things and getting this wrong and getting really weird errors. Okay, so that should be good, and this should be set to 1. Vertex attribute, vertex location 1. Okay, so we've added another whole set of vertices. I mean, they could be called vertexes, but they're the colors in our, and this says 75, so let's see if that worked. It should just change the color at first, but then we could see that we could change any color of any Hopefully it doesn't crash. It does crash. Why? 1, 2, 3, 4. Why did it crash? That's so sad that it did. It doesn't say anything. Should have just worked on. We did it right, theoretically. So I got something semantically wrong, I think. Some syntax crap. Let's see, maybe let's take this out for a second. I don't think it's the shader. I think it's something to do with the vertex array being bound. I forgot like one other thing. Okay. We've got this vertex array bound location thing, right? This doesn't even use this vertex bound location thing. What is it for? If this one doesn't use it, we don't need it. Let's go rip that out. Oh, it's because the shader is not being attached in here. No, we need it, sorry. Oh, okay, vertex VBO, VBO1, VBO2. So we need to generate more VBO buffers. That's right, that's what it was. How did I do it without doing that? Okay, vertices. Where's the VBO buffer? Oh, okay, so where it says gen VBO buffers, just set that to 2. But also, we need this VBO object to be an array of 2, so it doesn't like override some weird part of the memory. So we transformed it from a int to a double array pointer. Okay, error converting, so we just need like an ampersand sign, or we need to remove the ampersand sign. So it's like not a reference to a reference. Okay, I'm just getting the syntax wrong. It should be this. Gen buffers. Oh, okay, so when we bind the buffer, we have to go like this. Bind buffer 0. And then before we bind the colors, we need to do colors that size times float. We don't need to do that here. How is it doing that? Bind buffer data. Yeah, in this case, it's pulling it out of 2 different arrays. It's a little different setup. It's a little more advanced setup. This one is a little the simpler setup. So that's always fun when you move from that setup to this setup. Then you get really confused. What didn't I like? Find array data. Can't believe I'm getting this wrong. 399. Oh. Okay, delete 2 buffers. This cleanup code. Still very mad at this. Very mad. But I have the right code somewhere, so we just have to get the binding right. And this is one of the hardest steps, actually. This is like the most hardest step. It's harder than the stupid camera thing. The camera thing, you can just set up GLM and tell it to write your camera, and the bot will actually do it right. Kinda, and then you just mouse the camera. like we did in one of these samples. We'll just compile the other sample real quick, just to see what it did. And then we'll fix that. I think this was the basic 2 one. Basic 2. Just want to see what this is. It's always like good to try it like this. Oh, it like screwed it all up. Yeah, screwed up. This is the one we had. I think this one's screwed up too. How is that an error? Oh, I just forgot to save it. Yeah, this was ours screwed up. Okay. Like that one, just need to modify to where arrow keys modify camera. Okay, go back to this. We have a corrupt attribute array table. Alright, in order to fix this, let's go look at my other, like, lower code. I think it was somewhere like a nice game, or before nice game. I was trying to do it more of this style. It was all like one big old array. Just like a big vertices array. Then I was like, how do I remodify this thing? I tried to do things like memcopy, and it was like a lot of fun. Alright, so here I say, oh, you do have to do this. I lied. In the other one you don't. When you have another array, it makes it so much more nicer, but here you have to skip over. You have to do this void star 3 times size of float and put that into the end of the vertex attribute pointer thing. Bind the buffer and then set the buffer to 0 and bind it. Huh. Okay. So at least we're going to fix this rather quickly. And the number is how many bytes it jumped over. So if this is 3, on the next one it would be 7. And we have to unbind it. I have to do bind buffer 0, I believe, like right here. And after that one too, let's go double check the other code just so I'm not like guessing. Bind array buffer. GL array buffer, GL array buffer. Yeah. Let's just clean this up just a little bit. Okay. See if this helps. Will we get gnarly crash? Okay. Expected the token. Who cares? It's just dumb errors. Something's still wrong. It's always great. Now I'm very sad. How can I get this wrong so long? What else is there? Oh, here it's just 1. Oh, it's not 2. Set this to 0. It's not right though. You said like an extra buffer for no reason. Oh, so we need to start at 3 and go to 7? No, wait. Now I confused myself. Oh, we need to put a 1 right there. Whoops. Yeah, at least put a 1 right there. But I think it could be inside the same VBO. Yeah, it could be inside the same VBO, so it's on the same memory. Ugh, it's like so annoying. Okay, let's fix everything though. We don't need to. We just need to make this VBO 0, gen buffers 1. Make it 1 VBOs. Binary buffer 0, binary buffer. We don't really need to unbind it, I think. But when we delete, we do need to delete only 1. We may have to pass it in as a reference since it's only 1. That's made it confusing. Alright, so it's red, so we fixed it. That was it. Just adding that 1 in front of there. So there's a bunch of steps in that step. So let's like change colors. Let's color the cube a little bit. Set. Oh, the cube's got a lot of vertices, actually. Let's go 1. Like this. 0. 0, 1. 0, 1. Alright. There'll be more. To mess with. Let's just see. We don't see what we modified. Where's the front face? This should have been the front face. Really? Bottom face? Top face? Right face? Left face? Cube. But we did modify this face. This should be the front face, right? Huh. Oh, the Z, the back face. Maybe the back face is the one that's facing us. Let's just put a bunch of 1s in here. Maybe the back face is actually in the front. Oh, maybe. Oh, we do see through it. So we modified like 3 of them. Yeah. Huh. What face is this? Bottom face, top face. Let's modify 3 and 4 in top face. Let's see which one's like facing us. Just by modifying stuff. Oh, it's not that one. Right face. Let's modify 3 triangles inside of it, it's faster. Okay, that's the right face. It is on the right. Why is front face like not getting modified? Let's try it again. Let's remove all the red off of it. Nope. Here's back face. Okay, here's back face. Make every single RG, make every single green 1, and 2 of the bottom ones just green. Maybe the back face is in front. Yeah. Or what if we modify projection matrix to be normal? Is it already normal? I don't think it is. Or the sorry, translation matrix. It's 101. No, it's normal. What if I make this -2, like -20? For the translation matrix. Translator away? Yeah. Oh, that just like makes it fly away. Okay. What if we make it from -2 to like -1? Should be like closer to our face. Okay. It was 2. I'll make it 1.5. So we kind of get... But the problem is... This starts getting butchered. The aspect ratio. Did this used to be 1? Okay, that one. We modified that now. Oh. Trying to get it to move closer. Uh-oh. It's that FOV that screwed us. How come the translation doesn't work? Alright, translate by X or Y. Translate by Y by 2. Okay, that moved us like to the front. Translate by X by -2. I should just tell Grok to write a... Okay, so it moved it to the left. Makes sense. Translate the Z. Maybe the Y by 10. We need to move a little closer. It's just annoying. Okay, too close. We're too not far. -10. 10 is like a high value though. Should have tried 1 before 10. -1. Huh. Okay, they just moved it down. Yeah, we need to be messing with Z. -2 to -4 is like dumb. Okay. Instead of -4, put 4. If it's too much, then we don't see it at all. If it was 0.1, then where would it be? Would it be right in our face? I hope so. No. -0.1. There. No. Negative 1.1? We know it'll show up at 2. Okay, it's a little better. Negative 0.1? Uh-oh. No. It's the minimum we could have before it just calls. Yeah, it's 0.5. For some reason these rectangles got really stretched, and then the cube lost its color. Let's see what else. They said it's a negative 1 for now, but it was negative 2. But you know, 0.5 is kind of, yeah, with that we could see some of that stuff. That's so screwed up though. What if we don't even execute translate matrix? Translate matrix gets put into the picture through temp. Again, remove it. Like we're back to the same problem again. Matrices. That screws us up. Just rotate this crap for a little bit. I still want to fix these matrices and then put the planes just straight up flat and rotate only the cube. But we'll need another attribute array for that. Or we could actually use a uniform and somehow pass in an index, but that also needs another attribute array. Okay. The projection matrix. I think it's possible to have two cameras and just split the you could split the screen, do multiple viewports without GL viewport by doing that, I think. Okay. Let's just try that. I have it somewhere in maybe this computer or that computer. Yeah, okay, so it wants to use GLM. Camera position. And GLM makes it more sense. It's easier to read the code, make sense of it with GLM. Okay, pretty much the same. Create perspective matrix. He's making a matrix. Create a function for it. It's going to be 1 divided by aspect half 10 FOV. Just kind of redefining the cube here, I think. Let's see what we get. I hope he... Yeah, he's going to use a... No, he's not going to use the index. Rotation matrix the same. Translation matrix a little different. Zoom in by closer camera. Yeah, so... Let's see. How's that different from mine? Yeah, like I was trying to do that. I was just trying to... Okay, so he did kind of the same thing I was doing. Instead of -1, so see. But I think he redefined some of the points of the objects. Maybe before he gave bad cube generation. You could also ask Bard. But that's like one of the things I kind of skipped over. Let's see. Proc basic to C++. I'll just make this real quick. And oh, that's such a bad error right there. If you do that, you like destroy your file. It probably, it usually will tell you can't do that, but sometimes it won't. Okay. Proc basic 2. This looks maybe a little nicer. Where's the cube? Okay, there's a green plane. This is kind of stupid. So where's the cube? And things are culling. See them just like disappear into the void. Right? Oh no. At different resolutions. Alright, let's change the transformation matrix. Did he keep the colors? I think he threw my colors away. Okay, so the front face of the cube is green. We need to just rotate the cube. I'm just going to tell him on this one, I think, to just rotate the cube. But he's going to get it wrong, I believe. I think we need field of view to be 60 degrees. Interesting enough, he's not using GLM, he's using CMath. That's actually cool. And translation matrix, what if you set this even camera closer, and move it farther, and put it -3? Okay, now we can see everything. Those things are all messed up. Okay, our cube is We need to add the depth thing to the cube. What if we stop the rotation? Save it like this. Make it basic 3. Destroy the thing. Recompile it. Okay. Now let's save it as basic 4. Then oh, the camera died. It died a little while ago. Okay, don't rotate. Zoom out a little bit more and rotate the cube. Now the cube starts after the triangle, so that's 10 vertices. And at those 10 vertices, we know the offset, and we can just sit there and modify that with the matrix. It's the first 3 in that offset. We'll let Grok do it while I zoom out here. Rotate only the cube, and I have to fix those planes and set their colors differently. Damn it. Okay. The projection matrix is I was going to do zoom out. Oops. 3 to -5. Basic 4. What is the other rectangle? Not the stupid thing. Maybe it like stole a rectangle. Bottom face, rectangle group. Yeah, I think it stole our rectangle. Piece of crap. So why we need our own code. Don't trust the AI, it'll steal the rectangles. It's like beautiful code. -75 to 25 at -75 to -50 y. Ugh. How dare it, dumb Grok. Main bottom rectangle. This is a rectangle. Alright, we might have to change its color. This is always red. Let's change it to blue or something. Or maybe just whatever 0, 0, 0 is. I forget what 0, 0, 0 is. I keep always mixing up what 0, 0, 0 is versus 1, 1, 1. Like, what color is that? Who cares? I'm just thinking to myself. Did I save that? Whoops. Damn it. How do I whatever. It's black. We need to move the camera a little bit lower, I guess. So let's go change that in transformation matrix. Y coordinate, set it to -2, maybe. -2. Oh no, I've destroyed my project. Don't set that to -2. Why though? It's correct multiplication of matrices, right? No, it's not. Something's wrong with doing that. The translation of y +2? I don't know. No, it's not gonna work because I'm not doing it right. It's not correct matrix multiplication thinger. What if we define another translation matrix with a y and multiply it? The thing to do is just keep unzing it. Yeah. Then we need to add depth. And instead of -10, let's do -7. As long as thing shows up, we'll be okay. And we need to fix the z depth and for the other rectangles. Okay, let's fix z depth, and then we'll fix cube depth. These rectangles, it's easier to change the z value of the first rectangle than to change the z value of all the rectangles, which are at 0, and this one's at 0, so I think if we set it to 0 minus 1, minus 0.1, it'll look like it's in the back of them. This is why it's like good to just start doing this. Like you're gonna like play a really long game of Age of Empires with your friends for like 12 hours. Okay. Something bad happened. What happened was I moved outside of projection matrix and I screwed it all up. Okay. Maybe it's actually there, but okay. So we have to move instead all of our other stuff into the front by changing 24 of these values to 0.01, but let's just do it to 1 first and then keep going just to make sure we don't like overwork. I know there's a negative 0.0, but that's not going to do anything. Okay. That did something. We have to move the main rectangle up. I'm guessing something's wrong. I wonder, well, it's 7.5 and this is from 50 to 7.5. This is, it should be on top of that, but why is it like that? Why does changing the z value move? Oh, it's because the way the perspective matrix is not right. Because of that stupid translation. That's messed up. That's so messed up. And look at that, there's only one triangle. Like, what's wrong with that? Let's move these to the front anyway. It's like death. so stupid. We screwed up the matrix. We should try this in Android and just see what the other matrices look like. Okay, why didn't those show up? That's like annoying. That just made me annoyed right there. Because weren't they showing up before? Okay, Grok Basic 4. Yeah, they were showing up, not all of them though. Huh. Grok Basic 3. Oh, I can't see anything on this. Yeah, I could see them. Not all of them are right though. There's like one that's like half missing. It's messed up. It's like it's generating boo-boo for us because of the whole sort of being lazy about math. Okay. We'll name, oh no. It didn't create an attribute here for us. Is this the right code? Like, what code is this? Cube vertices, triangle vertices. Oh, it did this. It like reorganized everything. It had to, but we can do it the hard way. Piece of crap. He cheated. Grok. Halo. Code 1. I have to like name that hallucination hood. Huh. Such Halo code. It's just like whatever. Yeah, this is what it made. Oh, fucking crap. Now it's dragging. Zooming in and out. It's got all these cool features, but can't see anything on the screen. Alright. Yeah, he like does this removed extra triangle since it overlapped. Oh, he like did this stupid thing. What's the draw count here? Vertex count. Crap. What is that? 60? Crap. Like, took out like 15 triangles. I don't even know what he took out. Oh, that's why they're not drawing. So we added 6, so there's 66, 75. Croc. Why are they? It's like triangles missing. Okay, so there should be another like 9 missing. So 66 plus 9. Yeah, I should get back to 75 triangles here. Oh, that's where they are. Okay. Now that makes sense right there. Okay. What else was it gonna do? Something in copy paste. Okay, we're gonna enable buffer buffer depth. We should do this like up here before the while loops, or don't keep. Okay, it's already enabled. Buffer depth functionless. What if we disable that? It's just like, what does that do? Front face of the cube. Fix this code to have regular orthogonal camera. So you shouldn't modify the shader. You should just modify the matrix. Create orthogonal matrix. Okay, good. Do this, like, I'll try to do this manually. Did he include GLM? He probably did. Oh, he didn't. Lucky. We'll just name this Bard Basic 1.c++, and just paste it, I guess. We could tell him to do this with perspective matrix and switch off and on. I like how he did this. This is very good documentation skills right here. Okay. Recycle. Copy paste. Okay, that looks a little nice. And it rotates. Okay, so there's a face of the cube that's blue. Like this looks more flat, I think. You can see little lines on the bottom of that. Okay. There's no escape. Okay. Gemini did get a little smarter, maybe. Before we used to like and also switching to create respective matrix when pressed P or O to orthographic. I think it's orthogonal, not orthographic. Whatever. Oh, he noticed I named it Bard Basic 1, and he already knows I'm going to name it Bard Basic 2. He's intelligent. I hope. I was actually going to do some LLM studying. It's like, this is like the best LLM studying ever. If you train an LLM, just tell it to write this. After analyzing all the GitHub code. It's like unlimited amount of data over there. There's so much of this type of crap. Okay. Did he do it right? I didn't read. He's orthogonal, yeah, so you added a variable. Create projection, you can create orthogonal matrix. Create projection, perspective matrix, sorry. Key callback, when you press O, when you press P. He adds the callback right here. Okay, everything else should be same. 75. He does it a little differently here. Size of vertices divided by 7. I don't like that, but oh well. It should work. Okay. It's like code review. Oh, it looks all really bad. Why is it so bad? Why is it all one color? Press P. Press O. Press P. Press O. Press P. Press O. Press P. Press O. Okay. Let's look at the shader code. Like, I think he just screwed something up. Where is the shader code? Equals attribute color. I don't get it though. It's different colors. Yeah, there's different colors. He screwed something up. Something is definitely not working. We don't see any other sides of the cube. We don't see the other rectangles on the bottom. He's just hallucinated. Alright. Just make sure that this is right. I know it should be 75, but if it gets screwed up or it's not 75, then it's just... Okay, that doesn't do anything. He did something sneaky to screw this up. I don't know if it was intentional or it was like orthogonal or perspective, but it was definitely like rude. I want to go to the vertex bound code somewhere. Alright, so yeah, bind it at 3. Did you get the thinger should get the vertex attribute location after you compile the shader. Indeed, he did. Very, very interesting. Just switch the OpenGL version. Oh, that's what it was. Okay. For some reason our cube is turned into a flat shape. I think he deliberately did that at some point. Yeah, our cube is flat. It doesn't matter for orthogonal perspective. It's just, no, it's not. I saw it to be unflat right now. I think it's not facing the right way. No, it's definitely flat. Our cube is flat. It's really funny how you did that. I think Grok did that too. He was like trying to optimize. Kind of smashed it right there. Good job, Grok. You did the Amazonian thing. Just crush those boxes with more boxes. I was caught off guard there. It's kind of hard to notice. What is it? The Z plane? Bunch of zeros on Z and negative 125. I don't know. Maybe it's the way it's respecting the depth. X is changing. Y is changing. I don't get it. It's all changing. It shouldn't be crushed, but for some reason it draws it like it is. Alright, we need to go rotate the cube individually back in our old example. That's what... We got some answers from those basics. change the color of our planes. And the manually done one is just more sane. I'm just gonna change these colors so they're like not red. And some like arbitrary coolness. Okay. Bad. Legal issue. Damn it. Oh, cool. Painter program. Fun to look at. I think we need to do -i, point this to some directory that has GLM inside of it. Now it can compile. Right now I'm going to call it Bard Basic 4. see what it cooked up. It really wants to use GLM better. What is it? Oh. Did it have enough space or what? What happened there? I think I copy pasted it too fast. Yeah, this compiler just does that stuff. Last time, what was the problem? Why the colors not be here? Oh, we see that the cube is cube. But we have these like weird culling. But we could at least like fly around now. Make sure our scene is being drawn. Yeah, if I get too close, I can't see it. Now it needs to have like separate cameras for separate modes. Crap. How did I fix the colors last time? You have to remove the Macintosh stuff, the two, and set the, just remove the core profile and GL true. Last time I set it to 3.3 also, but yeah. Oops. Where's the exe? Uh-oh. Let's rerun this. That got lost at the camera. It'd be nice to put the camera coordinates right into the title. Wow, it's like big. This example's funny because I have other examples, but now since I have this one, it's going to be interesting to compare them. Like you can move around, I guess. You could first person shooter around it. Ugh. Then I got lost. Like, where is it now? Is it set so the mouse can't, like... yeah, it is. It's like set so you can't... This is such a stupid thing. I don't think it's good to do that, because it'll like cause some sort of matrix multiplication thing. Whatever this is referencing, camera flipping. But maybe he just got it off some stupid website where it's like dumb. Like they intentionally did that because they wanted you to like not have anything call, so they can kind of like have like two of these colored things. Oops. How come it seems like you move forward but backward? Can you face the other way now? That'd be good to like put like a bunch of squares around me now and just figure out. No, yeah, 'cause I was trying to move around it. Huh. Let's try again. Why is their game bad? Well, it's not a really game, but... okay, and then right there, we just get cut off. Why? Oh, cool. We can move around it. Kind of. Uh-oh. Why does it disappear? Why? Why can we see inside the cube and it disappears? I'm so sad. Stupid state. This is probably why Vulkan is cooler. So now this like weird crap that like screws you up like this. Nope, still get the problem. Ah, I could see both sides. No, we can't. It'll still disappear. Kinda. Yeah, like where did that go? It went into like La La Land. There's like a limit. Yeah, you can see the backside of the cube. Not always though. Okay, can we just like rotate like crazy around it? Okay, that's too close. That's the problem. Yeah, there's like an angle right here that's like... Yeah, if you get too close. If I get lost, I press L. No, it doesn't do anything now. What? Oh, I know what the problem is. No meshing function called look at. That's stupid. Alright, I think I'm gonna go take a break. This is like getting stupid. It's like so sensitive in this view. But I want to get him back to the box. It's really hard. Alright. Oh, okay, so there's two matrices here. The camera matrix for the view matrix and the projection matrix for the projection matrix. I guess next time we'll add that. That's too crazy now. But there's also the model matrix. I mean, I knew that, and it's like part of my brain's already just been so fried since I started this. I was wanting to do this in Android too. This is a camera example. Well, I was trying to make it work. I replaced the main texture. And this one, to do this, we would have to modify the model class, I think. because they're going to be using indices here. Which is fine. Could it be done like over there, where it's just like defined all crazy? This. These. Purposes that we can do it, and just sure the colors. It's just like stupid. We could do more spam, but the interesting part would be still the cube and to set up the actual camera matrices all correctly. What do we have here? Is that a triangle? Or it's the robot? Let's disable the shader here for a second. I mean the texture. dumb. Did I get anything wrong with a comma? It's that, but what else can it be? It's the only thing I modified. One, two, three, four. This actually has the projection matrix thing set up right, I think. No. It's mad at me.